right, welcome back. This is another ALEKS topic. It's called Calculating Enthalpy of Vaporization from Vapor Pressure. And this is a fairly straightforward topic. However, I did notice that the explanation on ALEKS had you graph this data, and I think that's a little bit confusing. I think that it's definitely a good thing to be able to understand, and if you do understand that and you do that exercise, I think that that's great. But I think there is a little bit of a more straightforward way to answer this question. So if we look at the Clausius-Clapeyron equation, the natural log of P1 over P2 equals the delta H of vaporization. This is what we're looking for in this problem, the delta H of vaporization over R, 1 over T2 minus 1 over T1. So if you look at the explanation on ALEKS, it sort of has you use this equation and to make the equation of a line, graph this data, and then you're able to figure out what the delta H of vaporization is from the data from the line. And like I said, that's definitely a valid and a good exercise to do, but it's not necessary. So if we look at this data, we could say, and we could sort of see, well, we could call this P1, we could call this P2. Those are two different vapor pressures. So that would be P1, P2. Over here, I could call this T1, and I could call this T2, and that would be the two different temperatures. R is going to be a constant, so now I really have all the information I need in order to plug into this equation and solve for delta H vaporization. So, like I said, I'm just going to use P1, P2, T1, T2. I'm going to ignore this last data point. You could use it if you wanted to. It's definitely usable, but you don't need to. So let's go ahead and plug the information in and see what we get. So if we go ahead and do that, we'll get the natural log. P1 is this 0.00475 over 0.0246. That's going to equal delta H of vaporization, which is what we're looking for, over 8.314. 1 over T2, excuse me, and I'm going to convert that to Kelvin, so minus 83 Kelvin is 190.15, minus 1 over 180.15, I think I said Kelvin here, minus 83 Celsius is equal to 190.15 Kelvin, so this would be T2 converted to Kelvin, T1 converted to Kelvin, and now basically I'm just solving for delta H vaporization. So this is definitely more work, algebraically, but you don't need to graph the information. But you definitely, like I said, you definitely could. No harm in that. So let's go ahead and do this. I'll just sort of show you the way that I would calculate this out. I would solve for this first. You get a value of minus 1.6446. That equals delta H of vaporization over 8.314. I'll do the same thing here to get an actual value. That's minus 0.000292. Divide both sides by this value here. You end up with, make sure you can still see it, 5633.67 equals delta H of vaporization over 8.314. And then we can just solve for delta H vaporization. And that equals 46838 joules per mole. So units of our delta H should be joules per mole. And then since this asks for 2 sig figs, I just went ahead and converted this to 47 kilojoules per mole as my final answer. So this is what I went ahead and entered for this problem. And it's a little bit more algebra, right? But you don't need to break out Excel. You don't need to graph this necessarily. But like I said, you could. Okay, hope that helps.